Welcome everyone. Today we're going to be talking about Weibull Analysis, and also how to use it for fine-tuning your RCM decisions. My name is Ernesto Perez. I'm with Christopher Lopez. Christopher, welcome.
Hi, Ernesto. Hi, everyone. Welcome.
All right, so let's get started with a round of questions so you can jump in the comments and let us know where you're coming from and all that. So, first off, which reliability analysis tools do you know at this point? So, comment in your section in YouTube, uh, which um, which reliability analysis tools do you know at this point? And hopefully you'll learn some new ones today or during the series of these comments and these sessions of master classes.
Yeah. So today, I think the theme for today, this analysis, I think it's going to be very exciting for us to learn a little bit more. I'm excited as people get settled and we start getting everybody ready. Anybody is using any of those um, analysis in their day to day. Also,
Yeah, to me this is a I'm not really too familiar with the Weibull analysis. I'm definitely here to learn a little bit more about that. So I'm excited too, and I'll see which will be the engagement with that. And if, feel free to ask any questions you have during the presentation.
yeah, definitely. I really like this kind of analysis, uh, and this is a topic that it's been being a little bit more. I'm finding myself um hearing this kind of analysis constantly, statistical analysis and stuff like that. So it's very interesting that uh, other companies and people start implementing them because data is very powerful, especially in this time uh, that we're living right now. So if we gather enough data and we gather the right amount of data, I think we can make uh, beautiful analysis and maybe share beautiful stories of how our company is behaving, right? So
Yeah, beautiful. Definitely something that is very statistics in itself, they're old, right? But I guess the integration, or you know getting those numbers to work for you, is more and more becoming a trend. So definitely that's something that we need to engage more on. So is anyone that is viewing us today using any RCA strategies to find and resolve the cause of those mechanical problems? So add in the comments if you're using that, or use your emojis or anything like that. Let us know who's doing that.
yeah, as people start commenting and stuff like that, you know what, something interesting, Ernesto, I've been encountering is that uh, a lot of clients that have some sort of software in most cases. Oh, we have here currently using RCM3 over SEP and IM, and that's a beautiful segue because I was like trying to say that when we have software where we have database and stuff like that, uh, some clients like to uh, have all that information, but then they want a little bit more, and that is a great opportunity if you have a software and a database to analyze that. So great thing that you're using RCM3
Yep,
on your
thank you very
business.
much. And also, one of the things that I compare it to is, if you take too many pictures and you don't look back to them and perhaps bring out those memories or anything, why did you take them, right? So in the same correlation. Why are you taking or gathering this much information if you're not going to look back and analyze it and make decisions based on that and see how you're progressing throughout the history of your assets. So let's throw in another question. Does your organization use the Weibull analysis for anything at this point? You're seeing an issue with your failure mode library, bringing the content into the database. Is that it?
Okay, interesting. So this is something we can gather, and maybe our guest today can help us understand uh, this kind of stuff issue, right? So that's that's nice. It's not currently used, but want to learn. All right, all right. That's great. So today
All
we're
right.
gonna lay down the foundation for that, right?
Yep.
So
And
let us
today precisely, I
uh
think. Go ahead.
go on, Ernesto. Yeah.
All right, so I think today precisely that's the conversation we're trying to have. Not necessarily go to the details of what's your situation and how we're going to solve it, but at least start with a good baseline so that can get started, right, and make the right questions along the way. And for us, it's a pleasure to welcome you to another session of the masterclass, masterclass and set and network, which is designed precisely for this, to be able to interact with our viewers and use our experience to help you get the best out of your tools and get the most out of the history that you're gathering. So this is a partnership between Visual K, Conscious Reliability, and PDM Tech, also including the Hexagon company. Um, and this is kind of what we do.
Yeah, and just so you know, everyone that it's around, this is a monthly live free virtual session with the purpose of bringing knowledge from experts as well as creating an interactive community for maintenance professionals. So uh, keep in touch, especially in LinkedIn, so you can learn when we're gonna be providing this monthly sessions.
Yep, and make sure also you register to the platform. Essentially, this is where we gather all of our different sessions, and it allows you to stay updated with upcoming sessions as well, and continuity on specific reliability center maintenance procedures and strategies. So you can reach out and find the different sessions. Even this one, you'll see it in the portal, so we encourage you to see those as well as join us live so that we can address your questions and see how we can best fit your situation into the conversation.
Yeah, and when you're watching us live, you also have the opportunity to participate in our raffles. For example, today we have a 20% discount on the belt courses of your choice with conscious reliability. So, yeah, so every time you join us live, you have a chance to win.
By the way, if you also address or let's say attend to the different sessions and complete all the master classes, you'll be able to also claim a 20% discount on any belt course of choice with our partners.
So yeah, and also there will be the people participating will receive a certificate of participation. So uh, keep that in mind. And so we have
All
in the
right, I'm
audience.
seeing we have some experience with Weibull.
All right, looking forward. So you can learn a little bit more and maybe ask a couple more questions with our guests.
Yep. So you'll see in the comments as well the link to our portal, so you can register and use or see those sessions that we mentioned. Without further ado, I think it's time for us to introduce Jesus Sifonte, who will be our speaker for today. He's a thought leader, conference speaker, consultant, instructor, coach, specifically on asset reliability and maintenance. And he has a master's in maintenance and reliability engineering from Monash University in Australia. Um, and also he has ASNT Level 3A vibration analysis certification. So welcome, Jesus. Thank you for joining us today. I think it's been clear that you have been wearing many hats through the years. So thank you for joining us today.
No, thank you very much for the invitation. I'm really excited to speak about data analysis, specifically in the context of maintenance management. So, and you have been talking about data, and what we have seen through the years, Christopher and Ernesto, is that data abound. Sometimes there is a lot of data, and unfortunately, sometimes the data is not put into the right context. So we have a lot of data that we can't use. It's like a lot of loose ends. And once we put that data into the right context, then we can analyze it and make decisions. So in maintenance, in reliability, we have to make decisions every day. Sometimes we ask ourselves, should I continue operating this machine or this component, or should I stop? Should I repair or should I replace the component? What's the remaining life, useful life for that component? All of those issues, we have to deal with them day in and day out. And this is one of the tools that you can use to clarify how failures are occurring. So this is what I call a microscope. So this is a very fine tool that will help you understand how failures are occurring, the nature of the failure. So we have lots of tools in reliability. You have spoken about some of them. We can name like asset criticality analysis. This is a tool that will help you understand how relevant are your assets for attaining your goals, for tackling your risks, etc. Then you have RCA, root cause analysis. You will use root cause analysis for failures that are already occurring, and you want to understand the root cause of them and lay out a kind of a plan to resolve those problems. Then you have RCM, which is what you use for creating a plan. It's and a strategy, right? And Weibull Analysis is a tool that you will use to analyze and to understand better how failures are occurring. And we will see how it can be used in conjunction with other tools like, for example, RCM, and get the most of it, and use it to help fine-tune decisions strategies. So let's go on. People already know me. You have presented me already. So let's go to the main subject here. So we'll speak about RCM a bit. So because it is important that our community understands the reliability
Sorry, I
concepts,
think
right?
you're
The
not sharing
reliability.
your screen.
Okay, let me go back and share the screen. Okay, what about now? You can see it?
Now we can. Thank you.
Okay, so we will speak about some concepts, some basic concepts, so fundamentals of RCM, reliability fundamentals. So we then see the link between RCM, which is a very strategic tool, with Weibull analysis. Then we'll speak about Weibull. Then we'll see how the RCM-R model, integrate the two of them, and you will see some actual examples of Weibull analysis. So let's go and start with that. With it. So what's RCM? RCM is a process. It's a very specific systematic process that we use to determine what must be done for assets to continue doing what the owner of them wants them to do in a specific operational context. There are three concepts here underlined because they are very, very important. The first one, if we start with the last of the three, is operational context. We need to understand the environment the assets operate at. It is, you can speak about, for example, an air conditioner. You will say, okay, I have an air conditioning unit, and it entails a coil, it has a fan, it has a condenser, but I'm here in the Arctic, and you guys are in the Caribbean, and there are other guys here that are in the desert. So we use the same air conditioner, but we have different operational contexts of them. So we need to understand that concept very well, because that goes, that has a straight relationship with the maintenance that we have to apply to them. Then the other concept here is the operators. We have underlined the word operator, but that means the people who own the asset, what they want the asset to do for them. For example, I like my air conditioner to be at 70 degrees Fahrenheit, and I prefer to have low humidity, right? And I feel comfortable at 70 degrees. But here, my wife, she prefers 65 degrees because she's the owner of that asset at some point, and she turns it to the temperature that works for her. So not all assets have the same operational regime, right? So we need to understand that very well. And the other concept here is what must be done in terms of maintenance and changes for the asset to perform that, right? So this is the concept of RCM. And remember that we have said that in previous classes that reliability-centered maintenance is a very thorough process. It's a very detailed process. It takes time to do. So it is intended just for high criticality assets. So it is not a tool that you will use for all of the assets in your plant. You just select the most critical ones and apply RCM to them. When should you do it? The sooner the better. So right now we are applying an RCM analysis to a new design at a pharmaceutical complex here in Pennsylvania. So the sooner the better. But sometimes you don't have that luxuries. You are already operating your equipment, and the equipment is already going failures and things like that. So sometimes you look at those pieces of equipment that are low performers, that they have presented some quality issues on reliability, and then you apply RCM to them. So you can do it at the project stage of the asset lifecycle or at the operational stage. What does it do for you? It produces what we call effective failure consequence management policies. Those are solutions for a series of failure events that you will identify and you will evaluate. And part of those solutions of failure consequence management policies come in the form of maintenance tasks. Those tasks are prioritized according to consequences, and they target specific failure causes. What other decisions we can make with RCM? We can select some tasks, and we can assign them to operators. We can make changes to procedures and changes to the same machine. And in some circumstances, we even let some components to fail because we have already analyzed the consequence of those failures. So here you are preparing basically a strategy moving forward to operate and maintain that equipment so you can lower the risks associated to those failures to what we call tolerable levels. So that's what you do with RCM. Sometimes people think that RCM produces just maintenance because of the name, right? The name is there, reliability center maintenance, and people think that that's for the purpose of maintenance only, but it renders other than maintenance uh, recommendations, other things
Sorry,
than maintenance.
there's a question here. If we do have failure history or past maintenance history, then can RCM be performed at an initial stage?
Oh yeah, RCM can be performed at the beginning of the life cycle stage, like during the design. And what we do there, RCM is the endeavor of a multidisciplinary team. What you do is that you gather experts regarding the operation and regarding the maintenance and design of similar systems, and you use the collective knowledge of all of those guys, and you then list all of the failure events that may happen. So in RCM, we identify uh, three types of failure events according to the standard, the international standard SAE JA1011. The standard encourages us to identify three types of failure modes. The first one, and the most common one, is natural deterioration. How components may fail just by age, just by years of operation or months of operation. The second one is design flaws, because we know that day in and day out, maintenance people deal with design shortfalls in their machines, and those provoke failures as well. And the third one type of failure mode that the standard encourages us to also identify is errors, human errors, like mistakes done by maintenance people or operation people. So, and then with that information, we put together maintenance plans, and we also make changes in operation procedures and practices that we see that are not good practices. We modify them, we make machine designs, etc. So you can do it at the beginning of the life cycle, but there is, pros and cons. When you are at the beginning of the life cycle, you don't have the experience of failures with that system as such, the system under analysis. You do have experience with other systems. When you do it at the operational stage of the life cycle, you have the all of the failure history with you, and you can analyze. And there is when you can use Weibull, because you know what's going on, and you can complement the people's opinion on failures with what the failures that are actually using, and you can analyze them.
So there's kind of a correction here. He mentioned that he doesn't have, let's say, failure history or past history on maintenance. And is there any way that it can be performed? I think you kind of answered that
Yes,
on.
it can be done at the beginning of the life cycle. What you do, and you have the name of the colleague that asking that question, so I can speak
Yeah, I think
specifically
it's
to him.
Ronak.
Okay, so
Sorry if I'm
Burnett.
mispronouncing that.
Okay, so to that colleague, thank you for your question and for participating. So yes, you can still perform RCM at the beginning of the life cycle of an asset. What you have to do is, first of all, find a competent facilitator understanding RCM very well. That's very important. Secondly, gather a multidisciplinary team, people with knowledge of the operation, maintenance, and design in some case of similar assets, so they can share those experiences. And then you list all of those failure modes, and you have your team also evaluating the risks that all of those failure event pose, to your organization. Yes, you can do it. The sooner the better. When it is with regards to applying RCM. Okay, this is the RCM process. What you start with a functional analysis. That is, you do an operational context and you define all of the functions the owner of the asset wants the asset to perform, and also not only the function but also the level of performance those functions should be carried out. Then you define functional failures, then failure modes. You evaluate the effects of the failures through a risk analysis. Then you select consequences, that is, a classification of the failures into safety failures, failures related to protected devices, failures that just pose economical challenges, etc. This is a classification in consequence. Then you determine your proactive tasks. What kind of condition monitoring I have to do to tackle very specific, targeting every specific failure mode, and preventative maintenance. Not everything can be solved with proactive tasks. Sometimes you have to do redesign. Sometimes you have to do detection type tasks to realize that you have hidden failures. That is then default actions. So this is basically the RCM procedure. You have an example here of a worksheet. This is not a complete work, but at least it will give you an idea of what we do when we perform RCM. You see here on the headings, functions. There is an example here of a primary function. Here to circulate a minimum of 30 ppm. This is a primary function. Then you have a secondary function in yellow, and you have a hidden function, which is a protected function in red. This is step one. Then step two will be like the functional failure, in which ways the asset failed to fulfill the function. Then you have a failure mode. In this column named failure mode, you there establish all of the probable all of the probable failure modes or failure events that occur with their corresponding root cause, potential root causes. Then you do an evaluation of them. In this to the right, you have a failure and effects RPN. You come up with a risk priority number based on the failures impact on company goals, and we have a kind of a traffic light here coding. Whatever is red, whatever is yellow is important, and then we come up with tasks or types of tasks. To them, we call this, in the far right, we call these failure consequence management policies, which are later on converted into specific tasks with some frequencies of performance, and also we assign them to people. We convert them into a maintenance plan, and also you see here that we have redesigns, we have condition monitoring. There is RCM. You recommend a bit of everything, right? When we do RCM,
there's a few questions here.
Okay, go ahead.
Sorry. So the first one is, if they have a large processing plant and they need RCM, however, they need people who know the plant, probably people who have been there for a while, and they're having that challenge. Is there a way to get the RCM or an alternative to that?
I'm seeing, well, you speak to me. I'm seeing a comment in the chat. I don't know if they are related. Sorry, I got distracted with reading the comment. Can you repeat it again? Can you repeat it?
Yep. So the question is, they have a large plant, and it's been about 15 years old, right? And they need RCM procedures, but what they're seeing is that RCM needs their team to be very experienced on the plant, right? which is difficult to have because they probably have people moving frequently. And that
Okay.
means that doing the RCM can be a challenge for them. Is there a way or a workaround to that?
Yes. First of all, you need to get together, as you imply with your question, good people, knowledgeable people about the operations. But we're talking normal people. We are not talking rock science people. We are not talking scientific people or PhD people. So we need an operator of the equipment. We need people dealing with maintenance. They don't have to be, they need to be knowledgeable on the equipment, but their day-to-day knowledge is enough. That will give us information on the failure modes and on the failure causes. If you have a maintenance history with you, that will help a lot, because we may be able to gather info from there on failure modes. So
Hmm.
yeah, it's true that it takes time to do an RCM analysis. It is a lengthy process sometimes, but it is a really needed process if you want to protect, the functionality of your equipment. So I would suggest you to prioritize which assets you apply RCM to. So pick up the most critical assets, and yes, select people that are knowledgeable about the equipment. And it doesn't have to be a very large group. You can select 2 or 3 guys that are knowledgeable about, and the facilitator, select a very competent facilitator. It makes a lot of difference when you have somebody knowledgeable about the RCM process. That person will be gathering the right information from your people and from your work history, failure history.
So we have another question from the audience. So it's to help. Can you please help understand the difference between primary, secondary, and heating functions?
Sure, I can. So I think that we need a very specific class on RCM alone, right? But I'm happy to make that clarification for you guys. Primary functions are those related to what the asset mainly do. For example, you have a pump. What's the primary function of the pump? To provide water, right? Certain flow of water continuously at some pressure. So like here, you see that the primary function of this asset is to circulate a minimum of 30 GPM of caustic water through the SC system. Functions have to be written in certain way. So the standard tells us that you have to start with a verb. That's what you see to circulate. You have to continue with an object, caustic water, right? And then you have to explain also and to showcase a performance level. You have a 30 GPMs in there. This function here is totally compliant with the standard. So the primary function is what the asset mainly has to do. Secondary functions, the yellow ones here, we just have one here, but there are 7 or 8 different types of secondary functions. So we have secondary functions is like other aspects the asset have to comply with while doing the primary functions, while performing the primary function. For example, you have safety and environmental requirements. This is part of the secondary functions. You have statutory aspects of the business. If you are in the pharma industry, you have to comply with GMP, for example. If you are in the mining industry, you may have some environmental regulations. So whatever statutory thing you have to comply with, that's a secondary function. So just to mention a few, you have, for example, there is an acronym for that. We call it PEACHES. Then you have protective things. You have environmental. E stands for environmentals. A stands for appearance. There are some aspect about appearance that you need to comply with. It could be color coding, it could be cleanliness levels, etc. Then you have the C that stands for containment. That's what you have here, to contain caustic water inside the pump pipes and column at all times. So you not only have to pump water, but you have to contain it as well. And containment is part of the secondary function. Which C, you also have control, containment, control. So that is also another aspect of secondary function. With the H, you have health. So you should do your primary functions without causing health problems to the operators, the community, the maintainers, etc. So those are aspects of secondary function. Hidden function, by definition, is a function whose failure is not evident when they happen, evident to the operator. For example, protective devices. A redundant component. You have a redundant component that may take over when the primary component fails, but you don't know if it is failing or not because it is not working. It is a backup system. And if it is broken, you don't know until you have to use it. Okay, that's why we call that a hidden function. Okay, so hidden functions are related to protected devices, redundant components, or condition monitoring instrumentation. So I hope I have clarified it. So I invite you guys to attend one of our RCM classes. So we have a 24-hour class, a 3-day basic, and we even have a advanced and facilitator class. So for this introductory introduction here, I hope that you can understand what RCM entails. So what kind of benefits you can attain while doing RCM for a critical asset? You will experience a reduction in PM time. Okay, you will understand that there are a lot of tasks that you do that add no value to your company, and many other benefits like reduction in corrective time, employee motivation because they participate in the analysis, and so forth. So let's now switch gears to Weibull Analysis. Okay. Remember that with RCM, you put together the strategy. With Weibull, let's see what we can do with it. So we use Weibull for the following applications. We can forecast and predict failures based on models put together with all data. We can evaluate corrective action plans, evaluate new designs, maintenance planning, spare part forecast, warranty analysis, calibration of complex design systems, recommendation in response of service issues, all of that based on the analysis of all data. So if we analyze data, past data, we can prepare models that help us understand how the system will behave moving forward. So as you see, it emphasizes a lot in data. And we need not only data, we need quality data. So as I told you before, our Weibull analysis is like a microscope where you will define very specific failure patterns. And in order to do that, you need high quality data. To start, you have to break down your failure data into failure modes. So you need to separate, break down, classify all of the data that you have uh, into failure modes. What do we mean by failure modes? For example, if you ask somebody what happened yesterday that the machine was stopped, they can tell you the motor was broken or the motor failed, but that is not a failure mode. In RCM analysis, we say that and it's not that we say that, the standard says that when you define a failure mode, don't use the word failure. Explain how it failed or how it can fail. And we use what is called failure mechanisms. So we explain, instead of saying the valve failed, we will say that the valve had a seat, for example, wear. It has an internal pass, a leakage, or it seized, for example. So we can understand how the failure occurred. So if we say, for example, that the pipe broke, how it broke. So what are we having? We had corrosion, maybe. So we said corrosion, and now we have identified a proper failure mechanism so we can tackle. Or we can say, okay, the pipe, it wasn't the pipe, it was for example, the flange, for example. So we had a leak through the flange, and so forth. So we need to identify very specific failure mechanisms. Then we need to understand the age of the component failing, of the failing component. So it for example, corroded and we had a leak past 8,000 hours of operation. So we have to understand what's the age of the component at failure. But sometimes the data that we can gather from work orders in plants is not that specific. So we need to encourage our people to kind of fine-tune the way they present data, so we can analyze them afterwards. Age, when we speak about age means time, it could mean distance, cycles, etc. So we need to make sure that we comply with points 1 and 2. So we're speaking about very specific failure mode and we know the age. Otherwise, the data won't fit very well the Weibull model. So if we have multiple failure modes, you will see that you wouldn't have a straight line in the model. You will have a curvy type of plot, which is not good for analysis. What do we do with Weibull analysis in RCMR? So RCMR is an optimized RCM procedure in which we also use live data, or we use failure data and incorporate it into the analysis. What we do with data here is that we prepare probability plots, like the one you see here on the slide. So this is a probability plot of time versus probability of failure. And we do that to the failure mode level, level. So we determine reliability and we determine probability of failure at any operational point based on the models. And we are able to determine predominant patterns, failure patterns. That is, we are easily, by inspection, we can understand if that failure is occurring by age or prematurely, or it is a random failure. And it means a lot for a maintenance person. If you, for example, let's talk about day-to-day things. Let's say that you have in your car, you have a tire that broke, and it was, for example, a nail, caused that break, that situation, and because of that, you wouldn't do a PM to change your tires every certain kilometers or mileage because of a nail. It is basically a random thing. So you don't have to put together a maintenance plan for random stuff. You need to change the way you drive, or you need to change other things than maintenance. So this is what Weibull help us with. Sometimes we pretend to do maintenance to resolve, for example, a premature failure. Premature failures are not solved with maintenance. The premature failures are the result of poor designs or poor operations. That is not solved with a PM. So, but Weibull is a kind of post-mortem study that you do, and we'll let you know. This is like a lab, like a medical lab, like you do your blood testing and you see if you have high cholesterol or if you have whatever. This is what Weibull do to your machine. It will help you understand how failure are happening or occur. There is a lot of math behind Weibull, and I wouldn't, have the time to explain it, but I will present here the basics. The reliability functions for Weibull is this 11.10 here, 11.10 here formula, and it is coming from this book in chapter 11. This is the RCMR book, and in chapter 11 you will find that formula. It tells you that reliability at any time equals E is a constant 2.72 to the power of time. Time is the operational time of the machine divided by eta. Eta we call it the characteristic life of the machine, to the power of beta, which is the shape parameters. Both beta and eta are determined by the Weibull analysis. I will show you how to do that because you do that by inspection. The probability of failure is 1 minus the reliability. So the sum of reliability plus probability of failure equals 1 all the time. So let's say here that you had a filter, right? And you put together a model with the failures that the filter had in the past, and you come up with this reliability graph here in the left. It means that when the filter is operating 100 hours, for example, if you look at the Y value for that, it's almost 100%. That is that the probability of failure for that filter at 100 hours is 0 practically. So you have a 99.9 reliability of operation. As you see here, reliability starts at 100% and goes down as failures occur in the future, right? So similarly, you see that as the reliability goes down, the probability of failure goes up, right? So they are complementary all of the time. At 400 hours, you have 50% reliability, okay? And also the same amount of probability of failure. How do we interpret the Weibull plot? Okay, the Weibull plot is a plot similar to the one we have here in this slide. It is a time versus probability of failure, and this graph is exactly equal to the probability of failure one, to the one in the right here. The only difference is that we have a log scale. We have a logarithmic scale to straighten that graph and convert it into a line. So we can, by inspection, look at the line and we can interpret it easier. Okay. So this graph that you see here, that is curvy, we make it a straight line by just having logarithmic scales in both time and probability. And what we do here is that we plot the graph, and I will show you how to do it. And when you plot the graph, you put a straight line here, and you look at the properties of the line. What kind of properties? For example, the slope of the line and the one intercept here that is important. It will give you the two parameters of beta of Weibull. Beta is the shape parameter. It tells you how failures are occurring, and eta is the scale parameter, telling you what is the characteristic like for that component. So let me move on. How do we interpret Weibull? The most important parameter is beta. is that inclination here is very low, you have premature failures. If it is equal to 1, you have random failures. So failures are happening at any time with the same probability. You have a constant probability of failure throughout the whole life of the asset. It's like, for example, glasses. If you have a window glass, what's the life of a window glass? It's totally random. Okay, so you have random failures. If beta is more than 1, then you have wear out failures, and maintenance will do something good for you if you have components failing by age. Okay, so here we have an example, and I'll go ahead and do some others for you. So you see here that you have some failure data for a bearing, and you see that the data here is organized by age. So if you look into your system, into your CMMS system, your computerized system, you'll find the data by dates, right? Calendar. But Weibull doesn't understand calendar. You have to reorder this calendar time data into age. So putting the younger failures first and the older at the last, right? Once you do this, you have the coordinate for X here in this graph in the right. All you did is to look for the Y coordinate, and the Y coordinate is determined by the median rank formula, or the Bernard formula, and you use this little algorithm here, and you calculate MR, which is exactly the probability of failure for these points. Then you plot these points here in a Weibull paper, and you put a straight line here, and you crossing all of the points, and now you study this line, the slope of it, the intercept, etc., and you find the parameters. This is pretty much what we do. Here you see that the beta is 2.5 and eta is 825. This is the characteristic life, and this is the shape parameter. But I will go with some. This is how you do it. So you plot the points in the graph. Then after you plot the points, you draw a straight line, and then you determine the slope of the line, that is beta, and the intercept of the line with this dotted horizontal line here in the plot paper, that the time corresponding to that intercept is the characteristic life. So I will go and show you. This is the characteristic life here, 825. The characteristic life is a good thing to understand, to know, but the most important parameter is beta, because this is the one telling you how is the failure occurring, right? So there is some integration that we do in the RCMR model. In this fuchsia semicircle, we do RCM here, and then we do data analysis, and we compare the opinion that people have given us in the RCM analysis with what is actually happening in the field, and we fine-tune our analysis accordingly. So we manage 3 types of let's say, data analysis in RCMR. First one is RAM. This is the KPIs, reliability, availability, and maintainability. This will let you know how the asset is doing in general. This is at the machine level, but at the failure mode level, you will do Weibull analysis. And you select the strategies. Let me go and speak further about RCM. Weibull analysis. The first thing you do, you sort data by age. Then you determine the median ranks, which is the F, the Y axis values. Then you plot the points. You draw the straight line. Then you look for the inclination of the line or the slope, that's beta. You look for the intercept here with the dotted line, that is going to be eta. And you can also determine the average life or the mean life. So let's look and see some examples. This you will also find in our book, RCM Reliability Center Maintenance Re-engineered Practical Optimization of the RCM Process with RCMR. That's our book. You will find it in chapter 11 that we speak about Weibull. How do we correlate the value of beta with maintenance? If beta is less than 1, you have a premature failure, you do redesign, okay, or you run to failure, but you never apply maintenance. If beta equals 1, you never do preventive maintenance. You can do redesign if the failure rate is high. You could do condition monitoring. If beta is between 1 and 3, that's the perfect scenario for condition monitoring. If beta is more than 3, you have a strong wear out situation where preventive maintenance is preferred. So that's how data drives us, and leads us to make the right decisions with regards to the maintenance strategies. Okay, we have an example here. There is a filter in this pump. In the suction line, you have a filter, and it has failed 3 times. Okay, at 505 operation hours, 294, and 401. Let's do a Weibull analysis for these 3 failure occurrences. Okay, in order to do a Weibull analysis, remember that we need to focus on a very specific failure mode. What is the failure mode here? We have a strainer that is clogging. It's a strainer that is here in the suction line. We are focused just on the strainer, okay, in the strainer clog. We are not looking at the pump bearings. We are not looking at the valves. It's just a strainer, okay? Then we are going to determine the Weibull parameters and the predominant failure pattern and what kind of task we can use for it. This is how failures appear calendar-based, right? You had this sequence, but we need to change that sequence into age. So the youngest failure, 298, goes first, and the oldest goes last, right? Then we use the Bernard equation, and we determine the median ranks. Okay? So when we determine the median ranks, now we plot. So you see here the plot, 298 here corresponding to 21.2 probability of failure here. This is 0.1, 0.2 at 0.3. When we do this, now we look at the beta, which is the slope. Beta is 3.65. So we have a very steep slope. That means that we have a strong wear out. That is, that failure is occurring by age. Okay, there is nothing wrong with the design. There is nothing there that is occurring randomly. This is an age-related failure, and you can do PM to that. You have a strong wear out, then let's do a PM and change that filter at any proposed time. And there is also formulas to determine the timing for that replacement. Okay, you can clean or replace it at some point, right? But you have a strong wear out. Let's go and see another example.
Before we go on, there's a few questions here, and I think it should be a good time now. So there's a question regarding the median rank of bearings. Is that for any type of bearing, or is that just an example?
Okay, a median rank is calculated. Let me see if I can write in here. Okay, median rank is calculated. Are you seeing what I'm writing?
Yes.
Yes, we can.
With this formula, okay? You use a little formula to calculate it, and you will do it whenever you have less than 25 failures. You can use this formula to calculate the median rank, okay? It's for, depending on the amount of, what's I? I is the order of the event. So you have the order of the events here. So for the first failure, you will do then 1 less 0.3, right? 0.3 is gonna be a constant. N is the amount of data that you have. N is gonna be 3, right? So you have 3 failures. So N will be 3, and then you will add 0.4 as a constant, and you will multiply whatever you get here by 100. So you see here that it is 0.7 divided by 3.4 by 100, and that will give you this value of 21. Okay, that's the median rank. And that corresponds to the y coordinate of this point. So this point has these coordinates, 298, and then you have here 21, right? 21%. Equally, you will do the analysis, you will do the same thing for the second point. But here in the second point, if instead of 1, you have I equal to 2, right? Because it's the second one appearing in the list. Then you will substitute 2 here, minus 0.7, 0.3, that will be 1.7 here. Sorry for the mess here. So it's going to become, let me see if I can find an eraser here. Yes, I did. So that's going to be 1.7 divided by 3.4. As you can realize, 1.7 is exactly half of 3.4, and that will render you a value of 50%. So this point here will have 50% in the y coordinate, and will have the age of failure, which is 401. Now you can see the correlation between the median rank and how to calculate it. So these are, and thanks a lot for the question, because that helped to clarify how this works. The age is what you see in the x coordinate, and the MR of median rank is what you see in the y coordinate in this graph. Okay, these are the coordinates for each point.
Okay. There's kind of 2 questions that I think we can merge. One of them is beta related to the bathtub curve, and the other one is, I think, is there an easy way to use this, right? So using a software to calculate that data and that information, right? So
okay, what you have here, the bathtub curve is a concept, right? It is not an analysis. It is a concept. And beta is related. You can relate data. You can relate beta here to the bathtub curve. So here in the premature failure area, you have a beta less than 1, right? In the middle, you have a beta equal to 1. And at the end, you have beta more than 1. So this is how the beta relates to the bathtub curve. Okay, but the bathtub curve is theoretical. It's a concept. It's really a model showing you how an hypothetical part or asset that undergoes the 3 different forms of failing through the whole life it is shown, like that. This is the failure rate in here. Failure rate, and this is time, operational time, right? So yeah, you can relate the Weibull analysis to that too. So let's speak about a second example here. So we have a centrifuge filter saturation. That is, you have a filter that is clogging, and you have here the times when the filter, you have to stop the centrifuge and change those filters, okay? You see here that there is a variety of time here. You have 170 hours here, and then you have 350 hours of operation. And you have also 20 hours of operation. You have different instances in which you have to replace that filter. Let's do an analysis and see what's going on here. Because maybe somebody can recommend some maintenance tasks to this, or a redesign task. Let's see what we have to do here. We apply Weibull to it, and we see that we calculate the median ranks similarly, and we see that now the graph looks a bit different. You don't see a steep, like line that you saw before with the filter, with the strainer, right? That means that you have a very low beta. Beta is 0.8. That's a premature failure. And what can you do for premature failures? You have to redesign. But there is a concept behind redesign. Most of people in maintenance and reliability are either engineers or have a scientific background or have a very technology type of background. So you have electricians, you have mechanics, industrial mechanics, you have instrumentation people that have an electronic background. And we think when we speak about redesign, we think about machine. We have to change the machine, not necessarily. So a redesign in reliability means a change, a modification. Could be a modification of the machine, or could be a modification of practice, or a modification of a procedure that we would need to, or a tool that we need to perform better. So we need to make changes here. So we either run to failure if the consequence of the failure is not big, or we can live with that, or we have to redesign, but we never apply maintenance to it. Why? Because beta is less than 1 and we have a premature failure.
So Jesus, excuse me, there's another question, and I think this examples goes along with that question. It's regarding beta lower than 1. Can that be also be correlated with warranty?
That is a very important question. So there is something that we don't cover in the class. That is, it's an advanced case in the Weibull analysis. There is there is a third parameter called the minimum life. Okay. Most of the analysis we use 2 parameters, which is beta and eta. But we also have gamma, and here we are assuming that gamma is equals 0, right? And whenever you have the straight line, gamma equal to 0 is a good, is acceptable. But there is also something called a minimum life, and minimum life means the time to which the probability of failure is still 0. And that we call that the minimum life in statistics, and warranties are related to the minimum life. So the manufacturers, they have done tests, lab tests, and they determine a minimum life. And guess what? They will give you a warranty which in the minimum life range, right? That's why they tell you if it was your fault, you have to pay, because it was not natural wear and tear, natural deterioration. It happened to me, these days. So I called the insurance of my car and told them, I had an accident. I was taking the car out the garage, and the back door was, up. And I said, oh, wow, it was your fault then. Yeah, yes, it was my fault. Then the insurance, you have to pay this amount, and there is the warranties are, with regards to minimum lives. Okay. Let's
So
go.
it's safe to assume that the minimal life equals the warranty term.
Yeah, and sure, and it will be a bit less the warranty.
Yeah.
Okay, let's speak about bearing, because you have bearings. Whenever you have a rotating equipment, you have bearings in pumps and in fans, in turbines. Everywhere you have bearings. So here we have this data, operational data. See that the age of failure ranges from 13,000 hours to 47,000 hours approx. Right. So you have that range of ages, right? Bear in mind that this is the same application. This could be 4 different machines, but the same bearing, same speeds, same application. Everything has to be within the same operational context, right? So we have these 4 failures, then we have this graph here. What's beta? Beta here is 1.9, is about 2, right? You see that beta is not random, is not 1. Beta is more than 1, but it's less than 3. So we have that situation where we have a mix of random and wear out failures together. So when you see that transition, that's the perfect scenario for condition monitoring. So you have some couple of random and you also have some wear out failures together. So it would be easier for condition monitoring to find a potential failure condition. So whenever you see this, try to figure out how to monitor a health indicator of the machine. So here you have beta equals to 2, then you have eta, which is the characteristic life, around 33,000. So use condition monitoring and try to find a. Now we know that we can do vibration analysis for bearings, and we can do also ultrasound. We can also do oil analysis if that it is in a lubricated,
Yes.
oil lubricated. So, and well, as time came to an end, as a summary, we spoke about RCM as a very strategic tool to develop a strategy, a maintenance strategy, and also an operational and some other things and maintenance like redesigns. Then we explained that RCMR, which is Reliability Center Maintenance Engineer, incorporates live data analysis or Weibull analysis into its RCM analysis. We explained how to interpret the Weibull plot. Remember that it is going to be a straight line, and you will look at the slope of the line and the intercept of the line at the 63.2% probability of failure. That will give you eta. And then we saw a couple of examples with live data, with actual data. And it is very interesting because in our advanced RCM classes, in our REAM class, Reliability Engineering Applied to Maintenance, we encourage people to bring their own data. And the class becomes basically a consultancy session. So I let the people use data, do your own analysis, and let's speak about the analysis. Let's see if the decisions you're making without knowing that you had that data, is in accordance with what this technique tells you. I'm happy to answer further questions from our audience.
Yep, I think you left them wanting more. So there is one question here, and I think you've spoken about it a little bit, but it asks about what kind of software do you recommend to perform RCM, right? I think you covered a little bit of where the data comes from with your CMMS or EAM. I think someone mentioned the using Infor EAM, which now is Hexagon EAM. Um, but I think it's more than just that, right? Is there any tool or software that you use specifically for RCM?
Yeah, we right now we have developed our own tools and that we use at our organization, and we will shortly come up with a solution that we will share with our customers, but it is not ready yet at this moment. And when that moment comes, we'll be able to recommend. And I'll tell you what, we have seen lots of RCM software, and sometimes they're prepared by programmers, not by reliability engineers, and we have seen a lot of shortfalls. What we did in our organization, we put together our own tool that has all the reliability math embedded into it, and we'll be ready to speak about it in a couple of months, and have a couple of simulations, live simulations with our customers, and let them use it and share that. But with regards to CMMS, it is important that you have the right CMMS that can help you, and that you know how to use it. Because you can know about Weibull analysis, but if your data is garbage, you wouldn't be able to do an analysis. So you guys are the right ones to speak about CMMS and how to use it. And once you have that data very well organized, Weibull is a piece of cake. So Christopher, is your call, and to recommend CMMS and how to use it and how to get good data there.
Definitely. So, a question over here: how can the people from the audience find your book, Jesus?
Okay, Amazon has it, so you can just Google it in
I'll post the
Amazon.
link here in the comments, and we can also share it in the WhatsApp group. So we'll send that over. Um, any other questions? I see there's another question. In
Should
your
we?
experience,
Yep.
is it correct to use the Weibull analysis for all assets?
Yeah, whenever you have the good data and the analysis is worthwhile. So if it if you think that the case deserves to devote time, to do an analysis because it is a meaningful asset to you, yes, why not? Do it. Do the analysis. And the good thing is that it's a technique that applies to any type of equipment. It could be a static, it could be a structure, it could be a pipe, it could be a rotating equipment, it could be a heat exchanger, whatever. You can apply you can apply Weibull analysis, provided you're focused on a very specific failure mode.
Okay. I think on the last session, I guess the first one, we covered a little bit of how to prioritize assets based on,
Mm-hmm. Sure.
the criticality or how it impacts different areas within the company. Um, so I think the what's left is
You
to,
see, you hear that I have company?
yeah, you're gonna get bitten. All right, so I think the only thing that remains is our raffle. So remember, we are doing a raffle right now. Essentially, it's going to be a 20% discount on any belt course from Conscious Reliability and the team from Jesus. So yeah, Christopher, how do we join?
Yeah. So right now you should see a QR code in your screen. So to participate, use the QR code provided in the screen, and you should be in.
So, guys, I will propose you something. If our audience get motivated, we can do a Weibull analysis part 2 class. So that is, we can go over some other, we can speak about minimal life, we can speak about suspended items. So how do we handle assets that has been stopped from operating, or assets that were parts replaced preventatively, and how do we take into account those preventative replacements into the Weibull analysis? That is also a subject that is very practical, because we have failures and we have PMs, happening. So how do we handle that? If we had those filter change that happened preventatively, and we have some filter change that happen upon failure, how do we handle that? So if our audience deems it necessary and motivates, get motivated, we can do a part 2 of this class in Masterclass, and share our experience with our audience, and have fun together.
That sounds actually wonderful, really, because yeah, there's a lot to cover, and 1 hour it seems to be so little time where we are just grasping the concept, right? So uh, thank you
Yep.
for that.
All right. So I think we are ready to start the raffle. Make sure you join the contest by texting Weibull Analysis or hashtag Weibull Analysis on the WhatsApp chat, and we'll decide shortly what will be who will be the winner for this.
So you have two ways to participate. Remember, we have the QR code in the screen that you should be seeing, and there's also a link in the comments, just in case. Okay.
Let's give a few minutes for people to join. So, Christopher, what did you think about this masterclass?
I think data is beautiful, and when we can uh, tell a story out of the data we have gathered, it's more beautiful still. So yeah, and this masterclass is a it's a good starting point to write stories using our data.
Mm-hmm. All right. So, the other thing that I saw here is that someone asked again, how can they get the link to the previous masterclass, and we'll pull that up right now. Essentially, that should be the portal for this one, the previous one, and any upcoming one um, that is scheduled for I think the next few months. All right, so we'll send the link again, but you can join that portal and essentially make sure that you can join and stay connected.
Yeah, and if you stay connected, remember this is a monthly masterclass. So every month we'll schedule a new masterclass, so you can join and gather, ask questions, and build our community here regarding our maintenance.
Yep, yep. Um, yeah, Jesus, thank you very much for joining us today, and definitely is something that is going to be of a lot of value for a lot of companies. So definitely, thank you very much for joining us again, since you were also the speaker or the master for that first session. But definitely, we're going to be expanding a little bit more on this RCM world. So let's get ready for the raffle. Everyone that is here, make sure that you join the chat and text it, and we'll select the winner shortly. Let me see. Sorry, technical difficulties. All right. So let's see. The winner. Do we have the winner in there? Let me see. Doing a contest here.
So I see Ernesto is building a little bit of suspense here.
Yeah, I'm doing a quick raffle here. So let me see who wins.
Beautiful.
Um, all right, let's do this. All right. Let's see who wins. All right, we have Xuan. He's the winner on the chat. So we'll reach out with details, but we'll see the winner in the chat, and we'll send the details for the 20% discount that you just won.
Congratulations. So I think we're there, right? We're in the finish line here with this
Yep,
masterclass.
I think it's there. I think there's nothing else to do here but to say goodbye and thank you everyone for joining us today. Christopher, it's always a pleasure to share hosting with you. Jesus,
Likewise.
thank you very much for joining us today,
Thank
and
you for inviting me.
we'll see you on the next one, team.
Bye, everyone.
Bye.